and the National Center for the Biotechnology Workforce. We've been doing this for about 10 years. And during that 10-year period, we've had roughly 60 speakers that have been involved with us. We know that we have had at least 3,450 people who have attended the lectures face-to-face. And due to the wonderful relationship we have with the Center for Transformative Learning here at SciTech, these lectures are also being broadcast and recorded for distance and follow-up learning. If you ever want to see one of these and you're not around, you can go to www.biotechworkforce.org and you can view them from there. And now it is my great pleasure to introduce Mr. Russ Reed, who is the Executive Director of the National Center for the Biotechnology Workforce, and he will introduce our speaker.
Good afternoon, everybody. Thank you, Dr. Davis. It's my pleasure to introduce our speaker today, Dr. Simon P. Selwood, and his topic, Consumer Medicine, Democratizing Healthcare Decisions. Simon received his PhD in 1999 from the Department of Clinical Science, Newcastle Upon Tyne University in England. He immediately headed west to California to start his postdoc work at Stanford University's Department of Psychiatry and Neurology. He actually spent 4 years investigating Alzheimer's disease and genetics, and was fortunate to actually win a medical school dean's fellowship award. Being close to Silicon Valley, the science and technology boom of the early 2000s brought him over to business side of science, and so he worked with startups and mid-sized biotechs. He moved to Maryland in 2011 with his wife and children, and as most of you have seen who saw the poster, he's obviously a very good family guy, having a picture of his beautiful wife and beautiful children. He started a company called BDBioPharma, and then he joined SoBranBioScience in 2012, where he presently works as Director of Business. For those of you who don't know SoBran, it has a location in Greensboro in the Gateway University Research Park. I know Simon because he's a fellow board of director of the Piedmont arm of the North Carolina Biotechnology Center. And I've just had a chance to have some sidebar conversations with him and just found him to be a tremendously interesting individual. And so, you know, we like to have inspiring people come and talk to our students and our staff, faculty, and our administration, and he qualified as one of them. He presently also serves on the Maryland Tech Council Board of Directors, and this is something that I'd like to speak to him a little bit more about. He's actually invested in a Winston Salem startup. Interesting facts. He actually was part of a 5-man team that held the world record for the London to Paris Triathlon. And he presently lives in southern Maryland with his wife, 3 children, and a menagerie of pets. So Simon, we have a lot of questions for you today. So please give a big hand of applause to Simon Selwood. And folks, just as a note, as he's coming up, especially for the students that are here, whenever you see in somebody's bio a university that's in a distant place of some sort, I highly recommend you go to the website, you look at that university, and you try to picture maybe perhaps one day that you might go to that university as a guest speaker, or you might go there as a visiting student, or you might go there as visiting faculty, or as somebody that's been chosen to talk. It's just very interesting. It expands your mind and your horizons, and I'm sure Simon would agree with that. Simon, welcome.
Thank you. Okay. Thank you. Hello, everybody. So thank you. Thanks for coming out. Thank you to Forsyth Tech College and obviously to Russ for the invitation. My name is Simon, as Russ said, and about 25 years ago, when I first started my PhD, we were looking at 5 or 6 genes at a time, okay, which was amazing. It took about a week, but it was amazing. It was cutting edge technology at the time. We thought it was fantastic. 5 years go on, I'm off to California. We used a microarray gene chip machine. We were one of the first few labs in the world to use it. And we were looking at 20,000 genes. And again, it took about a week to look at those, which was just phenomenal. Fast forward to now, 20 years to now, and we've sequenced, people have sequenced over 26 million genomes. So not the entire human genomes, 26 million, but the important parts of those genomes. And we've actually done about 100,000. Again, I'm saying we, I mean humankind, okay? I'm not claiming any that I've done any of this because I haven't, okay? But that's an amazing amount of data that we can mine, okay? We can analyze and get interesting information for fun stuff, but also for really big changes in medical healthcare, the important stuff for us. Has anybody done Ancestry here? Nobody's done an Ancestry kit? Okay. Well, they're fun, you know, they tell you about your heritage. You can find out about your dog, what type of, mix your dog is. There's even an app where you can get your genetic information from your partner in you, and then you put it into the app and it tells you what your potential baby will look like. You can get stuff for everything now. It really is a burgeoning technology, okay? But we are at the very start of this technology. If you think, most people here can't remember a rotary phone, plug into the wall rotary phone, okay? But that's where we are. That's where we are in this genomics revolution. This is where we're going, This is an iPhone 8. I mean an iPhone 10, okay? But that's where we're going to be, and it's going to get there in about the same time, a decade or so. Okay, so we are in the age of the genome, okay, which is going to provide us personalized healthcare, okay? And I put this one size doesn't fit all because that's what personalized healthcare means, or consumer healthcare means. It's driven by the genomics revolution. It even, one size never fit all for anything, did it? Certainly not for drugs. You have 10 people with a headache, you give them an anti-headache tablet, 5 of them it works, 5 of it doesn't. And that's the same for the whole gamut of healthcare, okay? So the first question that you haven't asked, but you would ask, I'm sure, is why now? We've known about genes for decades. We've known about the human genome. Why now are we on this revolution, okay? And it's a combination of technology and price, okay? The first human genome was sequenced in 2003, and it took about 15 years, just under 15 years, okay, and it cost $3 billion. Now, the utility of that, obviously, for all of us, is there is none. But another 15 years on, it takes 2 days, okay, and $1,000 to sequence. So then doing large-scale sequencing becomes a possibility, and we have the computing power to actually analyze that data too. And I just want to go over a couple of terms, okay, to make it clear to everybody. All of us in here, we're 99.9% the same. The code to make a human is the same all over, the world, okay? There was 0.1% difference between us. Now, if you can think about 0.1% difference in anything, okay, you typically don't even notice it because it's so small. But obviously, it's 3 billion bases, so 1% of 3 billion is a ton. And those small differences do make a difference, obviously, okay? So there's those 0.1% of differences. Genes, okay, which are made up of DNA strands, it's the smallest part that creates a protein, okay, is a gene, right? That's about 1 to 2% of the genome. And then there's extra material between the genes, okay? So this should come clear from this slide here. So SNP, single nucleotide polymorphisms, okay, that's typically the 0.1% difference between us. It's not really, okay, but for all intents and purposes, we can accept it as that. You can get that for less than $50, okay? So you can do that today. You can order a kit and go get it and find if you have susceptibility to a whole bunch of things, you know, breast cancer, lung cancer, you know, whether you respond to caffeine or not, whether you move in bed when you're asleep, okay? Exome sequencing, which is 1 to 2%, they're all the genes that code for proteins. So we're made up of proteins. So that's the protein coding stuff, okay? Again, less than $100. It's amazing. Whole genome, it's 95%, because 5% is difficult to code and really is just structural. $1,000, that's just, it's phenomenal, I promise, okay? And if you can see this, the emerging social genome, how this is going to play a role, okay, in the future, it's going to play a role in every single aspect, okay, specifically for healthcare, but then also, you know, when you come to you know, breed, get a partner, you're going to want to know what their genetics are. You know, maybe you can screen as well, a test to remove whatever genetic problem there is with in implantation. Okay, but every single aspect, it's going to play a part in your life. So back to precision medicine and what that really means. Okay, it's personalized medicine for you, but it also is your involvement. Okay, this genomic revolution is going to provide us, you know, a diagnostic capability. Okay, so it tells you if you imagine when you're a baby. The first thing they do is they do a heel prick, they take your blood and they test you for half a dozen different things, okay? In the future, that's going to be, in the very near future, that's then going to be taken and you're going to get your whole genome done. And so straight away, you know, disease probability, you can tell if you've got, say, susceptibility to lung cancer, okay? If you know that as a child, you're not going to become a minor. You're probably not going to smoke, okay? Proactive healthcare, okay? If you suffer from familial hypercholesterolemia, okay? You get people that are, these people that are 29 years old, slim, athletic, and then they have a heart attack. They are the people that you know, have hypercholesterolemia. You will know up front. You can start taking drugs as a young person, you know? You can change your diet. Treatments, so pharmacogenomics, which is really treatment based on how drugs interact with you or how you interact with the drug. So warfarin is a key example. Okay, people take warfarin, blood thinners. A certain amount of people, 20% of the population, have really adverse effects to it. So you can figure out before giving them, you give them the right treatment. So how is healthcare changing now? Okay, how is it changing currently? So, not for the genomics reasons, but just because of societal reasons, healthcare is massively changing anyway. People are changing. Nearly half of the amount of people that you know don't have a primary care physician, okay? They prefer to look up on the web and, you know, go and get an over-the-counter medicine. 3/4 of US adults, you know, use the internet to find out about a disease or a problem. WebMD itself gets over 80 million unique visitors. So that's people going up, checking a disease, going away. 80 million people come online for that. Electronic health records are widely adopted. So you do a test, years ago, you do a test, not very many years ago, you do a test, you could move to a different state, you'd have to do the test again. Now you don't, that all travels with you. And also concierge medicine, which is not really readily available, but it's becoming available. The more it happens, the cheaper it's going to be. And that really is you pay the doctor up front, so you get better treatment when you actually go in for that treatment. The climate around healthcare has changed drastically too, along with people's perception. people are far more comfortable about sharing, information. We don't have any teenagers, but we know people who do, and it's amazing what they share online. We live in a much more of a personalization type culture where people expect things to be directed towards them as an individual rather than the one size fits all. So it's what people expect. We track everything with our phones. We're very mobile. We track how many paces we do, what we eat, what our cholesterol is. Okay, we're much better educated consumers, and we're more focused on our health. My grandfather, he was 95 when he died, and he died about 45 years ago. He probably never heard the term genomics. I mean, he probably rarely heard the term gene. Now you hear it everywhere, all the time. It's on the news all the time, or in comics or whatever. Only 3% of our current healthcare budget goes to prevention. Okay, nobody is happy about that, doctors or patients alike. Okay, and we have a much better understanding. Of genetics and what that can actually do for us as well. And then data readouts. If you remember seeing what a printout was from a doctor 10 years ago, it was like legalese. It was impossible to understand a lot of it. Now it's very consumer orientated. Okay. So healthcare is in transition, driven by this genomics revolution. Okay. If anybody's a medic here, okay, I'm not knocking medicine because it's the best medicine we've ever had in the history of the world, but it's practiced by guidelines, okay, and by treatment of the conditions, right? If you're 40, become 40, you go get a breast screen. Okay, 50, you get colonoscopy. 10% of people that develop colon cancer, okay, are under 50. So if you start developing it 48 years old and you don't get your first screen until you're 50, you've had that cancer for 2 years. Okay, you go to a wellness clinic once a year. They check everything. Your blood pressure's great for 10 years. On the 11th year, you go and they say, "Oh, your blood pressure's high. We should start treating you." They're treating you after you've developed the problem. Okay, there's no prevention there, and that's what genomic medicine gives us as individuals. Okay, if you've got your pinprick as a child, okay, and you're susceptible to breast cancer, you'd be getting screened at 18. Okay, you'd never develop the cancer, or you would know way in advance that you were developing the cancer. You could take elective surgery. Okay. Pharmacogenomics, currently there's 285 drugs, okay, that the FDA know about that don't respond to all people. Okay. How many of them actually have tests? How many of them do you do a diagnostic before you take the drug? Okay, very few. Okay, they know it, but it's not quite there yet. Okay. So you take a lot of drugs that don't even affect you, or they have negative effects. Currently, these 285 drugs, they just have a little black box saying this drug basically may not work. Okay, that's no advantage to you at all. Ethical issues. I bring this up because of large data, large power. Ethical issues always come up. I think the ethical issues are far outweighed. The good of personalized medicine far outweighs any ethical issues. Does everybody know Gattaca? Most people are quite young. Okay, if you've not seen Gattaca, you should look it up and watch that film. It's a fantastic film. Okay, so most people have this dystopian future idea that we're all going to be screened. They're going to know everything about us, and then we're going to be put into a job because that's what our genetics says we can do that job, and you'll be streamlined and you won't get out of it. That's what Gattaca's about. But that won't happen, okay? I promise that won't happen. I know it won't happen for a number of reasons. But there are ethical concerns, okay? Let's say you go and you find out you're predisposed to a disease. Should your family members be, told? Should your potential partner be told? There's already a federal law on the books and a lot of state laws that says employment and medical insurance cannot have any negative effects based upon your genetic readouts, okay? Other things, so life insurance can. They can do that already. But life insurance do it now, depending on if you're overweight or have high blood pressure. So it's just another pointer, another marker to set their goals. But children, if you find out you have something, some susceptibility, and your child may have it, the doctor has to ask himself, what's his requirement to allow the child to know. He's got to keep the patient, doctor-patient privacy. But what if he knows? What's the ethical issue for him? But anyway, there are laws. There are laws in place. New laws will have to be brought on as this becomes much more widely available. Okay. But I don't think they're bad. So we know we're at the beginning of the personalized medicine revolution, okay? Genomics-based revolution, really, okay? So what are some real examples, okay, that are actually happening now? Angelina Jolie, I'm sure everybody knows her, okay? She lost about 8 members of her family to cancer, including her mother. Her mother was like 52 or something like that, or 55. So she had tests for BRCA1, BRCA2. They're the 2 genes associated with breast and cervical cancer. It cost her $3,000, actually, by the way, as well. This was in 2013. $3,000 to get these few SNPs tested. Now she could get a whole genome for $1,000. So that's how fast it adapts. Anyway, she was told that she's got 87% risk for breast cancer, 50 for ovarian, and she chose to have, a mastectomy. Okay, that she still wanted children, so she didn't have her ovaries taken out. She didn't have a hysterectomy. Okay, then in 2015, she had some markers that maybe it was developing, so she had a complete hysterectomy. So she's on, hormone replacement therapy. She can't bear any of her own children, but they've adopted a bunch. So that's a big decision for her to make. But the chances of her, that improving her lifestyle is massive. It's huge. I mean, she could be dead. She could not be a grandparent. Now the likelihood is that she will be. And that can only be done by looking at your genes. Okay. And she looked at one. She could have looked at hers, her husband's, and one of her children's for the same price she paid for that now. And she'd know all of the markers. Plavix, okay, is the second most prescribed drug in America, okay? 15% of people that take Plavix don't even metabolize it, okay? So they're thinking that they're getting some protection, okay, against the stroke, and they're not getting any. So not only is it not doing its not only are they paying for it, it's not doing its job, it's having a negative side effect too. Okay. Currently, there's just a warning on the box. There is a genetic test available, but again, typically, it's not elected to do. It's more of you can choose to do it yourself. If you had your whole genome sequence, you would know what sort of metabolizer you are. Okay. That's about $1 billion per annum is spent on a drug that has no effect. Okay. That's where we are currently. All right. I don't think we'll be there in a few years' time, but that's where we are. Okay, leading cause of death. I put in the leading cause of death for North Carolina. The newest data I could get was 2016. But effectively, these are the same leading causes of death in the world. Okay, cancer, heart disease. The accidents is a little bit high. I don't know why, if you're all bad drivers or something. But anyway, respiratory disease, stroke. They're all the same things. Okay. 90% of these conditions have a very strong genetic component, okay? But most people don't know. We have the technology now, but most people don't know, okay? So we will continue to carry on, okay? I would hazard a guess that nobody here has gone to the doctor with their own genetic information and saying, hey, I'm susceptible to, this, can you, recommend? And here is no different than anywhere else. Nobody has, have they? No. Okay, good. So my question is, okay, knowing this, that you could have this information, who wouldn't want to know? Who wouldn't want to know? Okay. Now that's a bit of a leading question, because when I studied Alzheimer's, there is no cure. It's currently very difficult to treat as well. So multiple surveys have been done by multiple groups all over the world, and it came back the same thing every time. If it was like, do you want to know if you have a susceptibility to Alzheimer's? And it's always done to patients that had a family member who'd had Alzheimer's. Okay, so they knew what the disease did. 50% typically said they didn't want to know. didn't want to know if they had the condition or not, or they were predisposed to the condition, and 50% did. Okay, I think that's changing because people want to know a lot more about themselves. Okay, but that's something to bear in mind, that if you have your genetics tested, okay, get your readout, there's going to be information in there that you may or may not want to know. I personally want to know everything. I want to know as much as possible. And deal with it after. But if you do, you should always talk to a genetic counselor afterwards as well, because a lot of these genetic tests are increased chances. You know, you have a 10% increased chance, or 50% increased chance, or 20% less. So really, effectively, they're nothing. You can ignore them. I'd say they're not nothing, but you can ignore a lot of them. Okay, so what does this mean? Again, we are undergoing a paradigm shift, okay, in healthcare. We're moving from treatment truly to prevention. Okay, again, nobody wants this 3% of healthcare budgets on prevention. Okay, chronic diseases are 8 of the top 10 killers. Okay, which are diabetes. They're preventable, basically. Lifestyle changes or drugs, but you've got to get the drugs early, quickly. There are a number of health initiatives, okay, and the reason I put this down is because when this data starts coming out from these initiatives, that's when things will begin to change, okay. Large hospitals are getting centres for genomic medicine, okay, spending lots of money, and there are some really large-scale initiatives going on too, okay. Genomics England, okay, was launched middle of last year. It's the largest one in the world at the moment, 100,000 genomes, okay. North Shore University, Illinois, 10,000, and I believe they are taking candidates. If anybody's interested, just go online. NCBC, I did see they gave a grant to Mission Health. It was a pharmacogenomics. They were looking at drugs in genetics of people over 65. That data should be coming out soon, and everything is involved in giving better primary care and improved outcomes, and of course saving money. And I'm not saying that getting better healthcare is the equivalent of saving money, but when there's saving money involved as well, it helps to get people more motivated and do the change that's required. Okay, so sorry that was quick, but we are in the digital health revolution, genomic digital health revolution. Okay, and everybody should be super excited, because it means you're going to live longer. Everybody's going to live longer. We're going to, instead of treating the condition once we've got it, where there's going to be some preventative measure, okay? We have to consider some ethical stuff, but we're going to get more personal insight than ever about ourselves, about our family members. Some responsibility is going to come to the patient, so it's an exciting time. That's it. Thank you.
No one?
Great talk. So I don't know if Russ told you, but we have a next-gen sequencer in our lab if you ever want to see it.
No, I didn't know that. Yeah.
Have you gotten your genome sequenced?
Yes, of course.
Oh, have you?
By multiple companies, yeah.
Oh, okay. Cool. I was just wondering, sometimes I've heard that it's $1,000 genome, but it's $100,000 genome analysis. The bioinformatics, is that, and the computing power that you need, is that a real?
So legally, there's a limit on what they actually tell you in relation to, predisposition. But there's a free online software that you can load all your information into, and then scroll through it and pick out your own stuff. So my wife and I did that same thing. We found, we looked at our Alzheimer's, ApoE is the main, gene that indicates Alzheimer's. If you've got ApoE4, you're going to get Alzheimer's more likely. So of course, we checked on those things, and our ability to take in lipids and that sort of thing. So no, so yes, if you get it done properly, there's a limitation of what you can actually get done, but there's a number of tools out there that you can scan your own data with.
I enjoyed your talk. It was wonderful. I'm a little bit skeptical about the ethical component of this, and I'm a little bit hesitant to want to have mine or my grandchildren's all of our information available to whomever may actually be able to get it. And I know that ways that may improve health care, but I've seen too much go wrong with good intentions to fully buy in right now. I don't know if that's a question or not, but just a comment.
No, it's. I mean, It took me a while. I'm the same. I think exactly the same way. I mistrust anybody in a position. Is that we are being surveilled everywhere anyway. I mean, I don't know about you, but I texted my wife about a cross-country skiing machine a few months ago. I went onto my computer. It's from my phone. I went onto my computer. I have cross-country ski machine adverts at the top of my screen. It's phenomenal, So I went into Home Depot and I was stood in front of I just stood there. I was stood, and maybe this is coincidence. I was stood in front of the little, vacuums for the car. Later that day, I get vacuums for the car adverts. I thought, are they really checking where I am in Home Depot? Is somebody doing that? And of course, it's a sign from Home Depot. So I thought maybe Home Depot did it. But so we're being tracked and checked everywhere anyway. Okay. We are all going to be sequenced without a shadow of a doubt. There is no way we are not going to be sequenced in the very near future. There's too much value to be had. People that aren't. I don't think the government's going to mandate it. That would be a tricky one to get through Congress. But I think the value is so great that people will go along with it because it's going to be like having a mobile phone. I hate having a mobile phone, but you can't get through life without one. The value is too great. But the second part is the laws have to be put in place. Already there's a great federal law that says you can't be refused health insurance. It can't be used. And I say can. I know there's people do get a way around things, but there are laws in place, okay, to stop that. I think we need to keep on making sure, that the laws get put in place because we're going to figure things out as we discover more. There's good indication that your genes affect your personality to a large extent. Okay, what's that going to mean? When you start thinking dystopian future, you think, well, they're going to look and say, oh, I can see by your genes, you're not going to turn up for work regularly. Or you have a high propensity to lie, so I'm not going to trust you with the cash box, But I think we can get laws in place to stop that. And in England, my old boss, so I studied mitochondria years ago, which was they're very rare diseases. And the mitochondrial has its own genome, and you only inherit that from your mum, because the female egg is full of mitochondria. The mitochondria for the sperm are only in the neck, and then it goes off. So you can get grown women, but you get grown men too. But you get grown women that they are on the low end of cognition. Okay, that by all intents and purposes, they're classed as being cognition. They're fine, but when you meet them, there's something that they're not quite. I mean, normal is the wrong term to use, but they're not quite fine. And they're on the very low end of the score. Okay, it's a mental and a muscle disease. Okay, but whatever the nuclear background is, accounts for the mitochondrial genes that woman has. Okay, but when they go to have children, none of their children ever survive. They might get to 1 or 2 or maybe 10, and then they get muscle and brain wasting disease. Okay, because whatever the nuclear background is mixed with the father is not enough to sustain it. So a third of all spontaneous abortions happen because you have a problem with your mitochondria. So your mitochondria, because they generate energy, they're so important for everything. So now we have the capability. Sorry, it's a long. We have the capability. Okay, for a woman that has that's carrying a mitochondrial condition, you can get the egg, you can suck out all the cytoplasm. So leave the nucleus, suck out all the cytoplasm where all the mitochondria are, get a donor woman's egg, suck out her cytoplasm, and then have the egg. So it's actually law got passed in England 2 years ago. And my old boss, he's now a sir because of it. Contributions to medical science, yeah. But the most important thing he said was now his wife is a lady, which he's happy about. But 3-parent child, okay, and you know, I mean, we talked about it obviously years ago, and it's like, oh, it's a bit of a tricky one. You know, you're sort of playing God a little bit. You know, you're 3-parent child, but then if you meet the people who are suffering from that condition, and they just want a healthy baby, and we have the technology to do it. Again, it's an ethical. It's like, what do you do if you can do it and they want it, and you know, not? Why not? So I think, but the laws around that are incredibly strict because obviously it's always open to abuse. So I think as long as we follow up with laws, I think just the way society is, it's much more consumer driven. People have a bigger voice, don't they? You know, now than they used to. I think the benefits far outweigh, which is, but I thought exactly the same way as you. You know, I thought, I don't want my genes being out there for somebody to see. There was actually a great case years ago of a guy that was in a cancer study, and he would go to the hospital and he would get his samples done. He'd sign off his release form, you know, every time, and then one day he decided to read it, and it was basically, you know, you have no rights to whatever we find. Well, his genetic makeup made him really you know, resistant to. It was some disease, and that's why he was in the group, because he'd caught the disease but didn't develop any conditions associated with it. Well, they actually went to court because because they tried to patent his gene sequence, and he said, well, it's my gene sequence, and they said, we discovered it. So his claim was, well, Madonna, her ability to sing and be good looking is genetic. So she gets paid for her genes, so I want payment for my genes. And they actually settled out of court. But, so sorry, what was I going on for that for? Rambling. But it's basically laws have to stay in place. Laws have to keep pace, okay? But I think consumers will push lawmakers, because typically lawmakers don't do it on their own, do they? Unless somebody's pushing them to do it. But I think, yeah, the benefits are great, and I can see that, you know, people will push to keep those laws, keep it in check. Sorry, that was a long answer.
Thank you. I mean, this is a fascinating topic, okay? But as a humanities person, I think the thrill of not knowing life as it is out there is being taken away. I agree when you cannot have, when you have genes and you can actually make a healthy child because of what we already have. I think that's a fabulous thing. For Angelina Jolie, what's going to stop her from being hit by a truck?
Nothing, yeah.
Yeah.
Sure.
So she goes through all that. I mean, I could have cleaned myself up and I could just fall off the stairs and break my neck. So how much God are we playing here?
Oh no, it's a good question. It's a good question, you know, but and I, you know, from a I look at things in two ways. One, I look at it from a scientific way, and then other times I look at it from a, you know, a humanistic way. Aspect, you know, so much about life, and so then I start thinking less scientific and more about, oh, what is the implication of this, you know? But I can't help but think if you can, you know, you see people that are 15 years old, you know, getting colon cancer or breast cancer, their sequence, and it's like, well, it's a glaringly obvious. Well, that would just take a screen. That would take a screen. And then, you know, regular follow-up and cut the cancer out, and then you've saved somebody's life. Like I say, with colon cancer, it's amazing. 10% of people get it before they're 50. But of course, the cost of medical care, you know, screening everybody from 40, say, you know, but then you get people that are 18 that get, like I say, that get colon cancer and die. So for me, stop somebody from developing a disease that we have the power to cure, then we should do it. When it comes to going into the egg, like I say, with this, pulling the mitochondria out, okay, that's, to me, that's, in my mind, okay, just in my mind, that's skirting the line, because then you're going to say, yeah, I'd like my son to be a little bit taller or a bit more muscular. I want my daughter to have bigger, fuller lips, And of course, that information is nowhere near available, currently. There's so 15 or 20% of their sequencers that are sold in the world are going to China, okay? And already, okay, a lot of China is fine, but because the rules and regulations aren't quite as tight, okay, already you can get a service. You can't even get your child's DNA done in the West at the moment, okay? You've got to be 18, okay? Because they don't want people to look and say, oh, they're going to be a good football player. I can tell by their genes. They don't want that. But that's what you can get in China now. It's like, do this test. We'll tell you whether they're good at maths, whether they're good at reading, whether they have an aptitude for painting. And it's all rubbish. You can't possibly tell that at the moment. The other thing is, okay, it's not known fully, but about 80% of our genes, okay, going into our brain. Okay, 20% of genes code for the rest of our body. The brain is so complex, and the brain is what makes you as a person, isn't it? Forget about getting liver cancer or something like that. This is what makes the difference with you, whether you like music or, whether you are good at something, whatever, science, whatever. Okay. So the ability to pick and choose, and do stuff in the embryo, is it eventually going to come? Maybe, but hopefully we'll have laws against that, because I think that skirts the edge. However, even now, when people go to a sperm, it always seems to be in New York. I don't know why when I read these articles, but sperm banks in New York, when people go in, they want sperm from somebody who's educated, who's over 6'2" or something like that. In effect, they're making a designer baby already. And my gut feeling already, I don't like that, because it's like taking away, the chance thing. So to be able to fiddle around and pick and choose, I think is a long way off. Because the other thing to that as well, it's very rare that you get a single point mutation that has an effect. Usually it's multiple genes combining together, and we don't even know what they are. We might think, oh, there's some individual point mutations that cause diseases. Sure, you change that point mutation, the disease is solved. Okay, yeah, without a shadow of a doubt. But trying to create a condition by picking one gene is very rare. Usually it's multiple genes that have to be selected, with a certain thing to cause an effect. It's incredibly complicated. But anyway.
I have two questions. One is, with this idea of changing the cytoplasm to prevent the muscular disease or any other kind of genetic disease, there's probably no pure cytoplasm in the world, no totally disease-free cytoplasm. So how do you know that you're not exchanging one disease for another, only the second one might not show up for 30 or 40 years?
So with the mitochondria, it's a unique organelle, okay? Because it has a very small bunch of genetic material in there, it only codes for 13 genes, 13 proteins, and a bunch of RNAs, okay? It's incredibly well studied. And really, if there's anything wrong with your mitochondria, you just don't get born. It's so important for it makes energy in the cell. So without energy, you just don't, nothing happens, you don't get formed. So the few diseases that are around are incredibly rare related to the mitochondria and incredibly well documented. So when the cytoplasm is taken from the donor mother, her mitochondrial DNA has been sequenced. multiple times. I mean, sequencing is not perfect, so you have to do it multiple times to to get over any mistakes. So I had my mitochondria sequenced ages ago. My girlfriend at the time, she was doing a study and she needed a control cell line. So they immortalized some of my skin cells to have an immortal line. This basically you just give it cancer. And I had my sequence done of my mitochondria because it was needed as a comparison. Well, I think I was 4 bases in what's classed as the standard mitochondrial sequence. But the standard mitochondrial sequence is taken from a dozen people and they're added together. So if out of those dozen mitochondrial genomes, if there's a T in one spot, in 11 of them, in an A in that same spot, then they just say, well, it's T. So the mitochondria is unique because it's been so well studied and it's so rare to get any diseases. So the chance of passing a disease and not knowing it is pretty rare.
So my other question would be, you mentioned Ancestry.com, and as I understand it, Ancestry doesn't do health, doesn't give health information.
That's right, yeah.
But 23andMe does.
They give some.
Some,
Yeah.
yes. And so what do those people, once they have your DNA, to the question of accessibility to your information, so what do those services do with your DNA once this test is done? Once you've received the information, then is this stored, is this destroyed, or do you know what happens to this?
Yeah, so I mean, there's, I would read the small print, okay, because on ours it was like, can we use your sequence for research? And I tick no, and my wife ticked yes. Because I still have a slight, I don't want my genetic information shared. It's a selfish one because what we really want is we want everybody to be sequenced, and then we want to be able to mine it. Say, hey, this group of people here, suffer from colds 5 times more than everybody else. Let's see what genes come up, cluster together, see how it is. We made a diagnostic years ago for a Canadian company, and they had a gene profile, okay, of about 21, 22 different genes. It was just their expression profile. So how much mitochondrial messenger RNA was expressed from 21 genes, okay? And they changed whether they give chemotherapy or chemotherapy radiation or radiation based on the profile. Typically, with the type of cancer, it was a rare lung cancer. It was done on size. If it was small, you just got 1. If it was big, you got 2 lots of treatment, okay? That's how they did it. Well, this profile said, no, it might be small, but this profile says it's aggressive, whatever, you should give 2 types of treatment. And it was amazing data. But they can only figure that out if they've got enough people in the pile to try and mine that and find that data out. So ideally, we want everybody in it so it can be mined like mad and we can figure everything out. So from my perspective, it's selfish because I didn't want my data put in. I mean, we had it done a long time ago. We're going to go back and do it again. There's another service you can get, and we're going to get we had our exomes done. We're going to get the whole genome-wide analysis done. And we've had a chat about it, and already I'm like, yeah, we just put it in. We should put it in. It was, at the time I didn't want to, but I've changed my mind since, Yes. Yes, but there's ways around it. There's online software where you can load your data into it, and then you can analyze your own data. Yeah. And there's a number of them as well. There's a number of these online, computer geeks, that want to help people out by putting the stuff up free. Oh, hi.
Simon, great talk. Can you hear me?
I can hear you, yeah.
Okay, well, great talk. And question I had was, this is a college, right? And we have students here, and they're learning now. kind of vision what, directions they should be thinking would be great jobs that aren't necessarily here yet, but are coming down the pipe? That make sense?
Yeah, golly. I don't know. I mean, a lot of this is automated machinery stuff. So even though the results are technical, the technique is very technical. The actually running the machines is, once you learn how to run, when you first start, it's like any complicated machinery, it takes a lot of time and effort. But I think any career in science is, it's a good career. I'm sorry, humanities. Yeah, there you go. Yeah. Bioinformatics, exactly. I mean, gosh, it's that Moore's law that was on the chart. It's a computing power law, isn't it? And computing power is just phenomenal. The way it's doubling, every 18 months or whatever. It's amazing. But yeah, we're going to need computing power to and computer bots to actually understand, make real sense of all that data, and it's going to be so very complex. Yeah, I mean, there's 3 billion bases. You know what 3 billion? How many 3 billion is? It's a difficult number to comprehend. It's all ATs, Gs, and Cs. If you say AT, GC, AT, GC, if you say it at that speed, 120 of them a minute, you'd have to say it for 50 years to get to 3 billion. I mean, that's a huge amount of data. Saying that for 50 years, and then you would read somebody's code. Bearing in mind, of course, 99.9% of it is the same from one to the next. But you still have to funnel through all that data. Yeah.
I guess my question is basically more about the ethical part of it. So within my family, well, it's not blood related to me, but ALS is prone. So there are genes that can be owned, and if they are owned, that doesn't necessarily mean you're going to have ALS. So you're also supposed to not have it hit every generation, but we just watched that happen. My grandmother had it, my uncle had it, his younger brother had it. There's 2 siblings in between. We don't know whether they did or didn't.
Mm.
So, I mean, you're talking about taking information and putting it into a system, and we may not know enough about it to even say, we're going to rule this one out, or we're going to keep this one. So, I mean, I kind of wonder about the ethics on that.
So when you say, can you say that last bit again? You mean knocking the gene out, or?
Yeah, you're talking about taking genes out. Well, you don't necessarily know for every single gene, yes, this one's definitely got a problem. So ALS is a good one to look at. So.
Yeah, I wouldn't take genes out at all. Not at all. I mean, the actual, the mitochondrial one is a specific one to a very rare specific disease that is manageable. Okay, that's a unique thing. To go in and want to change genetic material, I mean, no, I didn't. We truly don't know anywhere near enough to know, that changing something, at the embryonic stage is going to have an effect. There's a few very rare things like point mutations that cause a disease that are well known but rare. Yeah, you change that one base, from a T to an A or something like that. Yeah, that can stop a disease. But we don't even really have the ability to do that just yet either. There's some good technology around that say is so accurate, it will change, one group only. Nothing is ever that accurate. What's accurate? If you do it 1 in 1,000 times, 1 in 1,000,000 times, we're on about 3 billion bases. You have to be the technology we have is not accurate enough, to make a pinpoint mutation. I wouldn't be confident about that. But the second point is, no, we don't know. But the only way we do get to figure it out, realistically, is if we sequence a bunch of people, we have their medical records associated with their genes. What you really want to know is everybody's genes, okay, what all those genes do, what they do in their lifestyle, okay, and what they suffer from, which is just a massive, data set. And we're getting some of it with the medical health records. And cross-referencing your genes, with your medical health records is key to really finding things out. But again, even with that, the genetics of, you know, your personality. Are you somebody that can have a drink and stop before before you fall over? Or are you one that once you've had two, that's it, I'm all the way until I fall over? You know, that for, 50% of that is going to be down to your genetics, 50% down to your background. So we can't just look at the genetics, alone. It has to be in combination with the medical records, health medical records. But then once we get that massive pile of data, then we can really start pinning things down. So I'm not sure if that answered your question, but.
I have two questions. Like you said, we do not know a whole lot more now from what we will know in the future. But we just have two cases that I'm going to ask you to comment on them. The baby that was genetically modified a couple of weeks ago came on the news.
Terrible. In China, yes. Yeah, that guy's probably in serious I mean, I hope he's in serious trouble. They keep on indicating he is. But yeah, I mean, unbelievably crazy. Irresponsible,
But what makes it then to be like that? Because it is responsible in your point of view. And the second one is the same China fellow that presented in Europe curing HIV from the patients that would be highly resistant to being overexposed to the same HIV virus. And of course, the research community didn't like it that he presented something that they were not aware of and ended up being shunned from his own work and all that. So how is it that some can have more control over some sort of data, genetics information, while other ones might not have that right to have it? So my question it is like, who is really controlling in whose hands when this information can be used or applied, and not actually or doing the pathways so they will not fall on their own hands, even though they might be thinking of good, which that's the end goal, and not necessarily changing to bad, because whoever is going to be in power later on, or whoever is going to be regulating, can change the laws as well.
Mm-hmm.
So that's my first one.
Okay, yeah, so there's a lot of questions in there. I start with the first one about the guy doing the changes. I mean, I always think if somebody makes a huge claim, they've got to have a huge amount of data to back it up. And I haven't seen enough to show that his claim, is true. Also, I find it unbelievable that he says, "Oh, I cured HIV." Also, I may have made them smarter. I mean, it's like, does anybody believe that wasn't the goal originally? I mean, he's pretending it's about HIV, but really, he's trying to manipulate them. And that is so ignorant. I mean, it's completely irresponsible. I don't know what bearing the parents had, but for them to want to do that is just unbelievably ignorant and immoral. I mean, moral, I know, is a personal thing, but it's like, you don't know what you're doing. We do not have the information. You are basically running an animal experiment on humans. It's, you just, why he felt he could do it, or why they thought it was the best thing to do, I have no idea. But there should be strict rules and laws against that, for sure, right. For sure. As far as you don't know who's in charge, who's in control, yeah, I mean, I think we have that problem now with Google. I mean, it's annoying as hell, seeing an advert for a cross-country skier because I texted them. I mean, it's like, how do they have that capability? So let me tell you something. This is very interesting, okay? So my wife started a small company, okay? And her the CSO, he wrote a patent. This to me, this is as scary as it gets. Always being recorded, isn't it? I better not mention their names. But basically, their patent, okay, says that it can pull down medical information from the web that's open. So if you text somebody and say, "Oh, my dad's gone in for a heart attack," they can pull that information down because it's open information. It's not protected. So they've started to gather medical information about you. Of course, on the positive side, on the one hand, it is gathering medical information. Eventually, they can link that back to your genes, okay? But it's not, to me, it's creepy, basically, isn't it? They're stealing the information that, even though legally is in open space, it's not really an open space, is it? It's a private conversation, you know, and you know, you don't want somebody listening and taking that information. So yes, for sure. The only thing we can do is make sure that there's laws in place. And as far as people in charge, I mean, we need real big proponents from the medical industry to make sure that the government don't have access. So again, a dystopian thought, you know, if you sequence everybody, you know, what if World War III breaks out, you know, just so I don't ruffle anybody's feathers, let's say England and America go to war, okay, but everybody's sequence is known, and we know that, oh gosh, 10% Americans have this gene, and we can pinpoint a biological tool to hit that gene. We kill 10% of them overnight, and it doesn't affect us. You know, is there a way to direct a biological weapon against, you know, genes? In theory, yes, okay, but in practice, that's a long way off, okay. However, I still don't trust the government, you know, to have our genetic information. I don't trust big business to have our genetic information either in that regard, okay? There has to be rules and regulations around it because it does have the power of us. The other thing, again, when it comes out in time about personality, you know, what appeals to somebody? I mean, you know, marketers, you know, get paid a ton of money because they're good at marketing, aren't they? And what does marketing mean? They appeal to something to make you buy something. Well, of course, your personality, you know, probably 50% is from your genes. So if they know, you know, this group of people has this makeup, we'll direct this advert to them. So yeah, there is potential for abuse, for sure. You know, anything that powerful, there's potential for abuse. We just have to make sure that there's laws in place and everybody is aware of them.
Yeah.
Knowledge is the best thing, isn't it, you know?
And the last question, you show in your slide that it took about 15 years to sequence the gene, and nowadays it takes only how many
2
months?
days.
2 days.
It's actually 27 hours.
Yes.
It's not even 2 days.
Right.
Yes.
And because of how things go so fast nowadays, we were told that you crossed the English Channel from London to back then. So
I was a lot slimmer back then.
How long did it take you back then, and how long will it take you now?
An hour and a half in a hovercraft. Yeah.
Dr. Selwood, on behalf of the college administrators, our faculty and staff, and our community, I'd really like to thank you for all the
Thank you.
time and energy that you put into this presentation. You have enlightened us in nature versus nurture fast forward and how we can use science to inform our future well-being. We'd like to present you with a token of our gratitude.
Oh, well. Thank you very much. Thanks, Wes. Appreciate that. Thank you.
And for the kiddies.
Oh. Thank you. Thanks very much. Oh, gosh. They're going to love that.
That was Tori Reynolds, who's our dean.
Oh, okay. Hello there.
Yes. Thanks so much, Simon.
Pleasure. Thank
Thanks,
you.
everybody.
Thank you.
Appreciate it. Thanks. That was great.
Pleasure. Oh, gosh. No, I'm good. Thanks. Yeah.